Hey, today we're going to be talking about sample spaces. So our first blank is obviously going to be sample space. And sample space is the set of all possible outcomes in a probability experiment. So it's every single option that could happen when you're given more than one choice. A tree diagram is going to be our next blank. And a tree diagram is kind of like our T-chart. It's a way to display what represents the sample space. So it's kind of just going to look like some lines going off of our choices. So example 1 says a vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or a sugar cone. We want to find the sample space for all possible orders of one scoop of ice cream and a cone. So we want to see every option that you can get with those two ice cream choices and those two cone choices. So first, you can choose your ice cream. So we can choose from vanilla or we can choose from chocolate. Now, if you were to order vanilla, you could have either gotten a waffle cone or you could have gotten a sugar cone. If you had ordered chocolate ice cream, you still had the same choices for the waffle cone or sugar cone. So then our sample space is just them put together. So we could get vanilla, I'm going to put V for vanilla, and a waffle cone. You could get vanilla with the sugar cone. You could get chocolate with a waffle cone. And you could get chocolate with a sugar cone. This is our sample space. It's the only options that we can have. So if they were to ask you how many options, we would have 4 options, or 4 arrangements is another way to say that. The next example, it says the school cafeteria gives students 2 choices of snacks. So you can get carrot sticks or pretzels. They also offer a beverage choice. You can get apple juice, low-fat milk, or bottled water. Find the sample space, so just our list, for all possible orders of one snack with one beverage. So let's first look at our snack options. I'm going to abbreviate. We could get carrot sticks, so that's C for carrot sticks, or we could get pretzels, so P for pretzels. Oops. Okay. If we got carrot sticks, we had 3 choices for our beverage. We could get apple juice, we could get milk, or we could get water. Same thing with pretzels. We could get apple juice, we could get milk, we could get water. So then our total sample space, we can get carrots with apple juice, carrots with milk, carrots with water, pretzels with apple juice, pretzels with milk, and pretzels with water. So we had 6 arrangements in our sample space, so 6 options if they were to ask how many, which they're not, but sometimes they will. Okay. On the next page, another example says Delmar tosses 3 coins. If all 3 coins show up heads, so we're looking for heads, Delmar wins. Otherwise, Kara wins. Find the sample space, then find the probability. So they're asking us to do 2 things. So first we want to look at coin 1. With coin 1, you could either get heads or tails. That's it. Coin 2, you can still, after we roll heads, you could get heads again. After you roll heads, you could also get tails. If you rolled tails the first time, you could get heads the second time, or you could get tails. Coin 3, if you rolled heads, you could get heads again. If you rolled heads, then heads, you could get tails. If you rolled heads, tails, you could then get heads. Heads, tails, you can get tails. Tails, heads, heads. So you can see this can kind of get crammed, but we're just looking for every option that we can get. Okay, so our sample space, I'm just going to put SS for sample space. We could get heads, 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 tails, heads, tails, heads, heads, tails, tails. So I'm just going in order of what my little tree diagram says. That's all my options for if I roll heads the first time. Then if I roll tails the first time, I can go heads, then heads. I can go tails, heads, then tails. I can go tails, tails, then heads. So I'm going to go over here. And I could get all tails. This is my sample space, or 1, 2, 3, 4, 5, 6, 7, 8 options there. So that answers the first question, but then I want to find the probability that Delamar wins. Remember, he was going to win if he got heads all 3 times. That only happened 1 time. So since it happened 1 out of 8 times, that's my probability, which is about 13%. Remember, with probability, we can just write it as a fraction. Sometimes they'll want a percent though. So that's 1 divided by 8. So you put the options that you want on top, then your number of total options on the bottom. That's what we covered with our first section. The next example says Peter and Linda are playing a game in which the spinner below is spun twice. If the sum of the numbers spun is even, Peter wins. If the sum of the numbers, are odd, Linda wins. Make a tree diagram to show the sample space and then find the probability that Linda's going to win. So we're going to look at when they spin the first time. So spin 1. You could roll a 1, 2, 3, or 4. I'm going to push this down, and I'm actually going to erase this to space it out more. You're going to need some space for this one. Okay. So that's all you can get for spin 1. Spin 2, after you roll a 1, you could then get a 1, 2, 3, or 4. Same if you spun a 2 the first time, you could get a 1, 2, 3, or 4 the second time. For a 3, same thing, so 1, 2, 3, or 4. And then if you spun a 4 the first time, same thing. Second time you could either get 1, 2, 3, or 4. So luckily they're only spinning twice. I guess this should be close over here. So we don't have to make another column. So our sample space, I'm going to put a plus sign in between my numbers since it says the sum of the numbers. So we have 1 plus 1, that'll give us 2. Then we could get a 1 the first time, but then a 2 the second time, that's 3. 1 the first time, 3 the second time, it's 4. 1 the first time, 4 the second time, 5. 2 the first time, 1 the second time, 3. 2 the first time, 2 the second time, 4. 2 the first time, 3 the second time, 5. 2 the first time, 4 the second time, 6. 2, nope, that's all I have for 2. Okay, so 3 the first time, 1 the second time, it's 4. 3 the first time, 2 the second time, it's 5. 3 the first time, 3 the second time is 6. 3 the first time, then 4 the second time, 7. That's all my 3s, so now 4 the first time, 1 the second time, 5. 4 the first time, 2 the second time is 6. 4 the first time, 3 the second time is 7. 4 the first time and 4 the second time will give us 8. Okay, so we wanted to find the probability that Linda wins. Remember, Linda wins if the sum of the numbers is odd. So we're looking for all of our odd options. So 2 is even, 3 is odd, 4 is even, 5 is odd, 3 is odd, 4 is even, 5 is odd, 6 is even, 4 is even, 5 is odd, 6 is even, 7 is odd, 5 is odd, 6 is even, 7 is odd, and 8 is even. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8 options for Linda. Out of a total, let's see, there were 8 odds, so 9, 10, 11, 12, 13, 14, 15, 16 total options in my sample space. That's going to reduce to 1/2, or a 50% chance that Linda's going to win. So it also makes sense that there's a 50% chance that Peter wins, but we don't care about Peter, we just care about Linda. So that's it for that section over sample spaces. The little tree diagrams is just a way to organize your information. And that's it.